Possibly one of the most common technical mistakes in machine learning is referred to overfitting. Overfitting is when your model captures patterns in your training data too well, meaning it doesn't generalize well to unseen data. Essentially, your model has become highly attuned to the noise in your training set rather than the signal. Here's an example. Let's say you wanted to predict which one of your coworkers would go out to lunch versus which one would bring one from home. Eventually, after memorizing the car for each of your coworkers, you learned who went to lunch by looking out in the parking lot, thus achieving a model with great predictive accuracy in your training data set. However, this model would be highly confused if you introduced it to your new coworker, and the predictions you made from the model were meaningless. One of the key hallmarks of overfitting is when you see a large drop-off in performance in your training and testing groups. Your model is likely overfit in the scenario. So how do we prevent overfitting? Now, as an aside, there's an entire section in the performance tuning course on handling overfitting, but let's high-level it here. One method is called regularization. In this approach, you introduce a penalty for overly complex features that reduce, or in some cases eliminate, the weights in the model. Two common types of regularization include lasso and L1 regularization. Each of these will shrink the weight of the coefficients in your model, but L1 can reduce the weight for some features to zero, thereby removing them entirely from your model. Now let's work through an example. Firstly, you're going to import pandas as PD. Next, you're going to load the breast cancer dataset from scikit-learn. Here, you're going to assign the load breast cancer function as df, and then you're going to load data from the df into the data frame, which we'll call BC. Let's go ahead and run the cell to see the data. And there we go. You can see the features in the dataset, as well as the target variable here at the end. Now we're going to use the data to predict the incidence of breast cancer. To do this, we're going to run logic regression models using L1 regularization to prevent overfitting. As always, first you'll want to do a train test split on the dataset. To do this, we import the train test split from scikit-learn. Now let's go ahead and run this. Next, you're going to want to scale your features. To do this, you're going to use the standard scaler from scikit-learn's preprocessing package. Many models can be affected by outliers, some very severely. So this step is necessary. Next, we want to execute the cell. Now let's create a predictive model from the dataset. To do this, we're going to use a logistic regression function, which we're going to import from scikit-learn's linear model package. In our logistic regression function, we're passing in a penalty term L1. And note this C parameter, which we've set to 1. By adjusting the C parameter, you can vary the degree of regularization you'll have in your model. Now let's go ahead and run this and observe the accuracy in both the training and testing sets. Great. You can see we have a 98% accuracy in our training set, and we also have a 94% accuracy in our test set. Both of these are very accurate, and also notice there's a small drop-off in the training and testing. So there you have it. In machine learning, always review the accuracy from the training set to your test set. If there's a large drop-off, you're experiencing overfitting. To treat overfitting, consider using regularization in your model.